Good morning and happy Monday. Can you believe it's June 1st already? Doesn't feel like it, but hey, it is. So these are our last set of notes. We're gonna finish up with the word problems from this chapter 9, trig rules. So it's not too bad of a chapter if you like geometry, and the formulas are always there in front of you, so that's a good sign. But what happens now with word problems, people get worried about word problems. If there's a picture, label it. If not, make a picture. But the thing is, the complaints I hear from students in the past, I don't know which formula to use. Well, if it doesn't ask you to use area, don't use area formula. So if you're not sure, try the law of sines. And if you don't have enough information for a proportion, then ditch it. It's the law of cosines. So that's my advice to those of you who are never sure which formula to use. Let's take a look at this example here. We have a famous leaning tower, was originally 183.5 feet high. And at a distance of 129 feet, so there's P at the center of the Pisa. It looks like the Pisa, I'm assuming it's Leaning Tower Pisa. But if you walk out 129 feet, there's another spot Q. We know we're 129 feet away. The angle of elevation, so the angle of elevation is when your eyes look up towards the top. This angle here is given to be 65. Find the measure of angle P. Now here's the thing. To find this angle would have been nice if I had this side, which I don't. What I do have, I notice, I have this side, 183.5, and this angle. When you have a side opposite the angle, classic law of sines. So step one, I'm going to set up the law of sines, 183.5 over sine of 65. I do have this side here, 129, but it's actually facing opposite the wrong angle. Not a problem. We can find angle R. 129 over the sine of angle R. Cross multiplying and solving for the sine of angle R, get this decimal. And second sine, we get 39.6. The difficulty of this question, as you can see, it spells the naughty word angle side side. So we have to rule out the other angle, the supplementary. So if I took the answer I got from the calculator and subtract from 180, I have to question whether or not 140.4 would work. Well, obviously it can't, because if you add 6,540, you exceed the number of degrees in a triangle. Believe it or not, if a question like this comes up on the IB exam, if you don't rule it out, you lose 1 point. Go figure, right? But the one we keep is 39.6. That's angle R here. That's not the angle they wanted. They wanted angle P. Well, step two, find the measure of angle P. We know there's 180 degrees in a triangle. Subtract out the other two, and voila, there's your answer, 75.4. It is 3 sig figs, so I'll leave it as such. Not too bad of a problem. Really requires us to narrow down which formula to use and to buckle down with our geometry. Don't forget everything about the triangles, okay? Example number 2 might remind you of physics, working with the resultant and the two forces, maybe. Those of you who've had physics or will have physics, this will look familiar to you. So we have two towns, town A to town C, and then actually 3 towns. So one distance here from town A to town C, they tell us is 32. Then town A to town B, they tell us is 48. So and they also give us one more town here, I thought. Yeah, given that town B to C, so from B to C is 56. So if we draw in the arrows to all these towns like on a map, we have a triangle with 3 sides, and it's scaling, by the way. So given that town B is 56 kilometers from town C, find the size of angle CAB. Now again, that's something that's relatively new for us. Angle CAB, when they put the angle vertex on top of A, I know it almost looks like a party hat, like a birthday party hat with, streamers and balloons, hats. If you rewrite this, it's equivalent to stating that the vertex is angle A. So I'm going to try to find this particular angle using law of cosines. So setting up the law of cosines, 56 squared equals 32 squared plus 48 squared minus 2 times 32 times 48. The cosine of the missing angle. Remember, tidy up a little bit with your PEMDAS, but these two are not like terms. So if you remember, we're going to subtract 3,328 from both sides. And that's how I got negative 192 equals this negative 3,072. Dividing both sides by the negative 3,072, the negative signs cancel. I know the fraction reduces, but that's really not the point of the question. I really want to find angle A. So off to the calculator, what I do, after I turn it on, second cosine, 192 divided by 3072. I don't even bother writing using the fraction feature. There's your angle. Okay. And two more word problems I have. Number 3. I love number 3 because I've seen questions kind of like this on the SAT. So the accompanying diagram shows the plans for a cell phone tower that is to be built near a highway, busy highway figures. So find the height of the tower. So I put H here for the height of the tower to the nearest foot. So notice there they give us the provisions what to do for rounding. Now before I start this problem, based on the information I was given, I just used my geometry facts. For instance, this is a straight side, also known as a straight angle. Straight angles have a degree measurement of 180 degrees. So that implies this angle and this angle are supplementary. So that's how I found 115. Then I have two angles of 3. So I add these two up and subtract from 180. Get this little wedge here to be 33 degrees. Likewise here, I have a right triangle here. 90 plus 65. If I take that sum and subtract from 180, that's 25. So before I do any trigonometry, I'm just going to use my geometry facts and fill in the missing angles. Now the problem here, we have an obtuse triangle, right triangle, and they share a common side. Kind of like, you know, for instance, Mrs. Brainerd's room is right next door to me. Her smartboard wall shares the same side as my smartboard wall. We have a common boundary. Same thing here with the hypotenuse of this right triangle. So what I'm going to do, I'm going to ignore the right triangle for a moment, pretend it's not there, and I'm going to try to find that missing side. So if I'm trying to find this missing side, I'm going to label it X. Its opposite angle is 32 degrees. I do have this 100-foot side here, which is facing opposite the angle 33. So I would use that in my law of sines. So X over the sine of 32 equals 100 over the sine of 33, cross multiply. Now, I don't want to round too soon because the question did state it wanted me to round to nearest foot. So what I did, just a strategy, I store that in my X. So off to my calculator, just share that with you what I did. 100, the sine of 33. Then I divide, 32. Let me do that again. 100 sine of 32. And then I'm going to divide by the sine of 33. So there's the answer I got, 97, blah, blah, blah. Store that under your X, so it's in my calculator. And I did that because I'm going to need that to finish off this problem. In order to find this height, why not use SOHCAHTOA? We did that back in February. It's still fair game. And I think that's why I had to cover that in my geometry. Haven't figured out why I have to do volume spheres and all that stuff, but it's in there, so we had to cover it. So SOHCAHTOA's sine is opposite over hypotenuse. So the opposite side is the H for height, not hypotenuse, height. So H over the hypotenuse X. Again, same idea if you want to think about it as cross multiplying. The sine is 65 times the X. So I'll just X, the sine is 65, and voila. There's the answer I get. And if we round to nearest foot, it'd be 88 feet. Okay, so I like that problem quite a bit. Last word problem. We have here two triangles similar to number 3, but there's no SOHCAHTOA involved. There's no right angle. So we have Rachel and Chris are considering buying a block of land. The land agent supplies them with the given sketch. Find the area of the property. Okay, so we're going to have to use the area form of a triangle. So what I did with my yellow highlighter, I highlighted this triangle here, triangle ABD. I have two sides and included angle. So I can go ahead and find that area, no problem. So the area of that triangle here was 1/2, 125, 120 sine of 75 degrees. And I got this answer. But I didn't want to round it too soon because I want to round 3 sig figs at the end. So I wrote everything I saw on my calculator screen. But then the obstacle here is this other triangle here, triangle CBD. I have a side and angle, I don't have the side. So that's why I'm going to try to find this missing side using law of cosines. So I have this side, and the included angle. So I'm going to find side A by using straight up the law of cosines. So when I type this in the calculator, I got a very large number, and taking the square root of both sides, I got 149. Now there too, I'd recommend storing that in my calculator. Now I only wrote 149 here, but what I did, let me share with you what I did. So 125 squared plus 120 squared minus 2 times 120 times 125 times the cosine of 75. So there's this big number, right? 22,260 point blah, blah, blah. I took the square root, which is same as raising to the half. And what I would recommend, again, I would store that into your x. So your x is now that final answer. So now find the area, 0.5 times x, times, looks like the two sides are 149. Oh, no, not 149. Me bad. 0.5 times the x times the 90 times the sine of 30. So the area there I get is the 3,356.984. So I wrote that down. So that's the area of the top triangle. So I had to add the two together, and that's when I used 3 sig figs. I got about 10,600. I believe the 0 between the 1 and the 6 is significant. I like that problem. It's kind of fun. Only because it gives you a chance to apply triangle, area formula of the triangle, along with log cosines. But once again, it has a common border, so you have to be able to separate the two mentally when you figure out your problems. So it's the last video of the school year, last day of notes. So hopefully this chapter isn't too bad. Send me questions. I'll be sending you averages soon. Let me know if you have any problems. Good luck, and we'll talk to you soon. Thanks. Bye.